Okay, so using this file now, I want to go over three things. One is AI, another is how to put spin on the ball, and the third is how to manage this game into functions so that it's a little bit more readable. And the first thing I want to do is AI because while it's great that I can control both balls and you can have this two-player game, I think it's kind of more fun if the AI is the one that's controlling the game. So I'm actually going to change this behavior here so that instead of like me pushing up and down, it's going to be the AI going up and down. And the AI for Pong is actually pretty simple. It's a matter of the AI wants to move towards where the ball is. It wants to either move up or it wants to move down, right? Those are the two choices. And the thing that makes the AI interesting is that you let the AI move only so fast, so the AI can't move as quickly as it needs to. Like sometimes the AI is a little bit slow. And the way we're going to make this is that the AI is literally just going to move so that its position is equal to the ball. All right? And that means that we're going to take this behavior here. We're still going to be moving the right paddle the same exact way. The only difference is that when we move it. So if I can replace this here and say, hey, instead of doing this behavior when I press the down key, maybe I can figure out if the AI wants to move down or up based on where the ball is, right? And it's actually very simple. If we have a bool that we want to create here that says, hey, move up. That's all it is, just move up. If move up is true, then do this. Otherwise, if it's not move up, you can actually just do an else here. Okay. So this is our AI. It doesn't ever move right now because this is never true. So right now our AI is always going to be moving down off the end of the screen, apparently. It's a little cheater. Which, yeah, I forgot to mention that. Yeah, I didn't add the constrain the paddle. We'll do that next. Let's just handle how the paddle is going to figure out whether to set this true or not. So I have this if statement now, and I've set it up so that all I have to do, the only work that I need to worry about is when do I set that thing to true and when do I set it to false. I basically condensed and simplified the problem down to the point where the only thing I need to think about is when do I need to set this to true and when do I need to set this to false. And what is actually the question I need to ask? When should the paddle be moving up in our game? When should the AI be moving up? When the ball's above it, right? So how do I know if the ball's above the paddle? If the position of the ball is higher than the position of the paddle, right? So in SFML, remember, higher is 0 and lower is 512 in our case. So if the shape is less than, if the Y position of the ball is less than the right paddle Y position, then I want to move up. And that's really it. So if this is not true, meaning that the ball is below the paddle, then we're going to move down. You guys see how the paddle is basically moving to where the ball is? Anytime the ball is above the paddle, it moves, and otherwise it moves down, right? And it's interesting because it's trying to keep the top left corner of the paddle lined up with it. See how it's trying to keep the top left corner of the rectangle. We can change that too, so it doesn't have to be the this. We want to actually use the paddle position plus. We're going to add the. We're going to actually do this. I want this to be true more often. Yeah. We have the size of the paddle. We're going to multiply this by 0.5 to get halfway, so that the paddle is so the halfway point of the paddle is where it's trying to keep it in line here. See now how it's trying to keep the midpoint of the paddle. And what's interesting is that we can make this thing this AI a little bit weaker by slowing down how much it can move. If we slow down the velocity of the AI to be 50 pixels per second, now it can't quite move as fast. It's still going going to try to keep on top of the ball, but now it actually overshot it. See how it's slow? I can't quite get to it. That's because it doesn't have any idea of predicting where the ball is going to be. And we can add that behavior too. Like we don't have to force it to always be on top of the ball. I mean, I think this AI is totally fine. But one of the interesting things about AI is a lot of it has to do with kind of predicting some behavior. So in this case here, the way that I play is I'm going to predict where the ball is going to go, and I'm not going to touch the ball, right? So if I put my paddle right here. Where's it going to go? Here. So that's kind of what Pong is. At a certain point, when the ball starts moving faster and faster, it starts getting harder and harder, right? Let's do this. So we have this thing slowing down every time it hits the wall. So why don't we make it speed up by 20%? Oh, one other thing too, we're going to make it speed up both sides by 20%, x and y. This will make it, if I'm multiplying by 1.2, that means that the velocity is going to get a little bit faster every time it hits the wall. It's just going to keep getting faster and faster until it eventually gets really hard to track. And the AI is going to try to keep on top of it, but unless you have some prediction, the AI is actually going to miss it. So we'll talk a little bit more about AI in a little bit too. I want to constrain the paddle movement too, because I don't want the paddles to go outside of it, outside of the screen. So let's just fix that right now. Left paddle dot get position. Okay. Alright, I'm just constraining the paddles to be on the top and bottom of the screen. Okay, so this is the left paddle constraint. I'm going to do the right paddle constraint as well. So here I'm going to do Control H, and then do Control left paddle, right paddle. And you got to be careful when you're doing this. This can easily ruin your entire thing. But I'm going to select this, change this to be selection, and replace all. So there's the right paddle is now constrained as well. So even though the AI is going to try to move down, we're going to pop it so that it can't outside of that. And what we can do as well is we can consider, right now we're just considering where the ball is. What we could do is do a little bit of look ahead too. Like we could say, hey, if the ball is if the ball is going somewhere, like in the future, you can actually move the paddle up to meet it. Which means that not only do you have to take into consideration where the position of the ball is, what you can do is take into account the velocity of the ball as well. So if I want to do some look ahead, what I do is I take the velocity of it, and I want to look ahead some number of seconds. How many seconds do you think this AI should look ahead to make it reasonable? Maybe like 1 second? Maybe like half a second of look ahead? Let's try 2 seconds of look ahead and see how it feels. What this means is that this if statement now has just changed to look at where the ball is, instead to look at where the ball is going to be in 2 seconds into the future. So all I'm doing is I'm just adding the velocity of the ball. And what's that? It's still too fast. Yeah. I think it still has issues because not only is it moving, not only is it trying to reach the ball, but it also just can't move fast enough because it's bouncing off the bottom walls. It's actually still trying to move up. Just barely misses. It gets juked out because it hits the bottom wall and then doesn't know that it should stop avoiding it, which means that if we really want to make this thing more robust, now we want to add behavior so that it understands that the ball is going to bounce off of the wall in the future, which is a little bit more than I think that we want to do for this time, because I want to make sure that we go over the other parts of it too. But the general idea is that in order to get this AI to be effective, either you can add look ahead like this. You can also consider speeding up the paddle too. So if we just made it twice as fast, for instance, that'll also make it a lot more difficult because now the AI is able to keep track of the ball pretty much on top of it, even though now it was previously unable to hit it before. Now it still misses it sometimes. And however fast you make this, basically the more it's able to keep up. If you make this thing too fast, though, it will actually be unbeatable. Like, you will not be able to beat it. Like, if I double it again, this is basically how hard the AI is. It'll get to a point where it can traverse the entire screen almost immediately, which means that it has no way that it can miss any of the balls. Difficult. All right, so let's add a little bit more behavior. Like, this is great and all, and this is very, this is like really sufficient for like a version of Pong. But like Pong really is all about like putting like spin on the ball so you can control the velocity. There's a lot of ways you can do this. There's no real right or wrong way to do this. I'm going to show you guys just how I do it. And really, putting spin on the ball, all it means is controlling the velocity of the ball in the y-axis, which means that whenever it hits the paddle, you can control whether the ball goes more or less in the y velocity, right? So here, what we can do is go to a place where we're doing our paddle collision. So here's where our paddle collision is. And right now, all we're doing is we're flipping the velocity here, but what we can do here as well is consider how the paddle is moving to control the velocity of the ball. For instance here, I can say, hey, I know that the paddle is moving up or down because that's what this if statement does. So why don't I make it so that I'll make another bool, moving up, player moving up, and I set this to false. I make another one that says player is moving down. Set it to this one to true. And by doing this, I'll know if I'm moving up or down to control the velocity of the ball. So how about I make it so that if I'm moving up when the ball hits the paddle, the ball will go up. Otherwise, if I'm moving down, the ball will go down, right? So that I can say, even if the ball is heading in a specific direction, I can make it bounce the other way, okay? So I have these two variables here, player moving up, player moving down. And they're both starting at false, but I'm going to use these guys to control the ball velocity as well. So I'm going to use these two. I'm going to go all the way down to where the ball is hitting my paddle here. This is where the ball is hitting. Ball is hitting the player paddle. And I'm going to say, hey, not only am I going to flip the velocity here, I'm going to say if player is moving up, I'm going to say set the velocity always to be equal to negative 150. Else, if the player is moving down, these two if statements here mean that if the player was moving up or down, I'm actually going to force the velocity to be a specific direction in y. Which means if I'm moving down, as long as I'm moving down when I'm hitting the ball will actually move down with me no matter where the direction of the ball is. So watch here, try to move up. And see how I basically put spin on it so it goes up instead. And I can move down, make the ball move down as well. So I'll make the ball move back down. If I want the ball to bounce normally, I just stand still. And the ball will bounce normally. See how I can control how the ball moves by just changing the velocity when I hit it? Let's see here. What's the velocity of my ball right now? Negative 150 to start. I think what I want to do here is I want to make these velocities the same to start. So I'm going to make this 200 here. And this is just to keep it consistent because I want to speed up the ball as well. So this is going to be 200 now instead of 150. I want to do a little bit more though. I kind of want to control how much English you put on it by how close it is to the edge of the paddle. Because I want you to say that if you put spin on it, the closer the ball is to the middle of the paddle, the more control you have over the ball. Because if you just barely touch the ball, I don't really want you to put that much spin on it. And this is great because this right here will control, like, hey, I can completely change the direction of the ball. But I actually want to make it so that I don't completely change the direction. Instead, what I want to do is I just want to make it so that it's a fraction of what the spin that I want to put on it is. Okay. So what I want to do here is I know that I'm going to set to negative 200, but I can make another variable here, which is a float, which is going to be called the power. And by default, the power is going to be 1, which I'm going to multiply each of these things by the power. Which means that sometimes this power is going to be based on how close to the ball is to the middle. So this power is going to be equal to the difference between the ball and how tall the paddle is. So if I get the ball position .y, and I compare it to the left paddle, this right here represents the difference in pixels between where the ball is and where my paddle is. And I'm going to just also consider it the middle of the paddle. Let's make another variable that's going to be called paddle middle y. This is going to represent the paddle position here. I'm just making a variable to make it easier. It's going to be the middle position of the paddle, which we know is going to be this right here. 5.5. So I have my power, I have my middle paddle position, and I want to get the difference between this and the ball, right? So when the ball, so I'm going to have my little my paddle here, right? And I have my little ball right here. So when the ball here compared to the middle here, I want to get this distance right here. Because the further away it is, the less power I want to have. So here, the power will be equal to 0. And right here, if the ball was right here, I want the power equal to 1, right? And likewise down here. So on the edges, I want the power equal to 0. And in the middle, I want the power equal to 1. Which means if I know the distance between these two, the bigger that distance is, the weaker my power is, right? The lower that distance is, the stronger the power is. To the point where if it's exactly on top of the middle of the paddle, I'm going to set the power equal to 1. So this is the difference here. And I know that here, let's say this is equal to 0, and this would be equal to the 150 position, something like that. I know that I can just take this, I can divide this by the size of the paddle. The size of the paddle here, let's say this is equal to 300. That's how tall the paddle is. So if I take the distance here, let's say the distance between the ball and the paddle here is equal to, I don't know, 150. If I divide the distance here by half of the paddle height, I will get, I'll write this out in a little bit easier to understand fashion. I'll just delete it. Paint is not actually great for this stuff. Let's do this here. So I know the ball's here. What is the distance here? We're going to say the distance is 150 pixels. We know our paddle is 300 pixels tall. So if I take this math here and I say, hey, get the distance from the ball to the middle of the paddle, which we know is 150, and we divide it by the size of the paddle times half, so multiply by 0.5. This means that in this case here, I'm going to get 150 divided by 300 times 0.5, which is equal to 150 divided by 150, which is equal to 1. Which means at the edge, this is going to be equal to 1. What if the ball here, I'll move this, is right in the middle? What is the difference between the ball and the middle of the paddle position? That's going to be equal to, if you look at our formula, the ball position minus the middle of the paddle. So it's going to be 0 here, assuming that's right in the middle. So I'm going to get 0 divided by 300 times, and then that's equal to 0 divided by 150, which equals to 0. So when the ball is at the middle, this number here is going to be equal to 0. When the ball is at the edge, it's going to be equal to 1, which means that I want to flip that relationship. I want the power equal to 0 at the edges and 1 in the middle. So all we have to do here is set power equal to 1 minus this value. This will flip it so that when the ball is on the edge, this value here will be equal to 1 minus 1, which will be equal to 0, and this one will be 1 minus 0. That's what I did here. I just put a 1 minus in front of it, and that'll give us the answer. One more thing, too, that we have to keep in mind is that this ball here, because it can be both above and below, this math operation can sometimes give us a negative number or a positive number based on where the ball is, which means that we need to take the absolute value of that number, which is just ABS in front of this, which will mean that this whole thing gets converted. Let's just see what this looks like in turn. I'm going to just print out the power here. I'm just going to do a cout spin power. All right. So that every time the ball hits my paddle, I get to see on the left here what my spin power was. 0.13. See how that number is going between 0 and 1? And the closer it is to the middle, the stronger my spin power is. See how my spin power went to be 0.5, which meant that as I'm moving, the closer the ball is to the middle, I get more control over it. See how I hit the edge, I didn't get very much control over it that time. But now I can add more power to it. Let's just review this here. I'm going to break this down to a few more arguments. I'm going to make more variables here. Ball distance. And whenever I have a formula like this, and sometimes it makes a lot of sense to break these out into variables, like so. And that way, I know that I want to take the absolute value of the distance of the ball divided by the size of the paddle. In fact, I want to use middle here, because I already did that. So I'm just simplifying this formula way down. Let's do this. And that's the formula broken down. So we're taking the distance of the ball divided by the, oops, this is the size still, divided by the size of the paddle. Okay, and we're taking the absolute power of that and we're subtracting 1 by it, and that's going to be our spin power. And our spin power is going to be used whenever we're changing the velocity of the ball, so that the stronger it is to the middle, the more of this velocity we get to apply to the ball. Where if we're basically hitting the edge of the paddle, we only get a little bit of this. All right. I know this is a lot, but this is basically like, you can also do this anyway. You don't have to do anything like with power. You can keep it simple if you want to and just make it negative 200 and 200 based on how you're moving. I like to have some amount of like skill involved so that the closer you are to the middle of it, the stronger influence you have over the control of the ball. Right.
Now, is that how you want us to set it up in our game regarding the power? Or
you don't have to set this up at all in your game. I'm not requiring you guys to actually add this. I'm more just showing you guys how ways you can extend Pong. The final project is not going to require you to put spin on it or anything like that. So, but if you wanted to, this is how you could do it. And if you wanted to do it with power, this is also, you could do it this way. Some people also do it based on the, they control the angle of the ball based on where it hits. So we can use angles, we can use some trig to figure out like the angle of the velocity that we want to apply based on how it hits the paddle as well. But we're not going to do that here. All right, so the final thing I want to go over before I give you guys the final project is I want to show you guys how to basically finish this up to use functions instead of doing everything inside one giant main function here. You notice here that our program now, with all this stuff added, has gotten to be about 250 lines of code to do everything. And there's a way we can simplify this, not just for the sake of reducing the lines of code, but also to make it a little bit easier for us to reuse the same functionality. And let's do this first with, I think the simplest thing to do this for is, we're going to do this for some of our collision code here. In fact, let's do this here for our paddle position here. Because what I want to do is all this logic here, you notice actually it's duplicated between the left and the right paddle. So one of the ways you can handle this is you can take this whole function, this whole set of if statements, and you can break this out into a function so that you can reuse what you've done before. Okay. And there's two ways I'm going to show you how to write this function. One is I'm going to make these things global variables, which, if you remember, means to move them out into the global space. And I'm going to show you guys how to pass these things in as pointers so we can modify them. All right. So first thing I'm going to do is let's make the left and right paddle constrained to the top and bottom using functions. And that's going to save us some code. Because both AI and I are both doing the same thing. We're constraining ourselves. First thing I'm going to do is show you how to do this by moving these into making these global variables. So I'm putting these outside of main. The reason why this is important because I'm about to write a function that's called Constrain Paddle. I'm going to make these things. Yeah, we're going to do this with this. Sorry, I'm not going to make these things global at all. I'm going to make these things. Let's make our function first. I'm going to make a function called Constrain Paddles. And this function, what I want it to do is I want to say, hey, here's a paddle, and I want you to give me back a paddle that's been fitted to the contents of the screen. I want to just pass in a paddle and say, hey, if this paddle is outside of the screen, make sure it's inside the screen instead. So all we're going to do is we're going to pass in a rectangle shape here. This is the type. Remember how when you write a function, you want to pass in the argument types to it? So here I'm going to have one parameter, which is a rectangle shape. This is my function prototype here. I'm going to intentionally write this wrong at first just to show you. This is the rectangle shape here. I'm going to go all the way to the bottom here, and I'm going to write this function called paddle. And this is the name of the variable I'm going to use here. And this function here is going to be, the only thing it's going to care about is is the paddle above or below the edge of the screen, and if it is, put it back to the bottom. And we actually already wrote that here. So what I'm going to do is I'm just going to I'm going to cut this out of here, like so. I'm going to go to the bottom here. I'm going to paste it here. And I don't need the right and left paddle anymore. I'm just going to do this for just paddle here. I'm going to replace everything that says left paddle with just paddle. And that function is now done. It'll take whatever paddle is there and we'll set it. I intentionally wrote this wrong. I'm going to show you guys what happens when I call this function. So where I was at before, now I can call constrain paddle. And I can pass in left paddle here. And I can constrain the right paddle here. I've now made a function that I can call that does this work for me. It makes sure that if I move my paddle, that it always will be within the right and top and bottom edge of the screen. I'm actually going to move this up a little bit to be right below. This is where I move the paddles. Put it right here. And so when I run this function, it's actually not going to work at first. And you might be wondering why, because we wrote it and we copied it, and it should just be working. So this is where a good example of putting a breakpoint in there is. So I'm going to actually run this. And I'm going to move my paddle above here. And I'm going to put a breakpoint right here. This breakpoint right here is right when I'm about to call this function for the left paddle. I'm going to hit F11 to step into it. And you notice where the arrow would jump down to inside this function. And now I have my paddle. Let's just get the position of this paddle. So there's the position of my paddle right here. 62. It's currently at negative 62.95. So if everything is working correctly, this if statement should be getting hit. It goes into here, and notice how it moves the position of the paddle here. Now it's at 0. That's awesome. So it actually is working correctly. And I go back outside, and let's examine what the position of this left paddle is now. Do you guys see how it's back to negative 62 here? Even though we changed it inside the function, this value didn't actually get modified. So if you remember, whenever you're writing a function and you have an argument that gets passed in, that argument gets copied to the function. Down here where my function is declared, this variable right here is a copy of what I passed in. Because whenever you're calling a function, it has to make a variable that uses this. This is basically like you did this. Like the arguments in here are converted into variables that live within the scope of this function. So the reason why this is making a copy is because we've told it by default, without specifying anything else, C++ will make a copy of whatever you pass in, which means now I have my left paddle. What it actually did is it took the left paddle, took all the variables inside of it, all the positions, all the dimensions of it, made a copy of everything, and then passed it to this function as a copy. And what we're modifying here is that copy. We're not actually modifying that original paddle. So what we need to do is there's two ways we can fix this. One, we can tell it, don't pass in a copy, just pass in the original. If we want to do that, there's a special character you can put in, which is an ampersand, which says don't make a copy of it. Instead, just pass me the original. Give me the original memory for this shape. So I put a little ampersand in front of it, which means don't give me a copy. It means pass by a reference to the paddle. And when I say making a copy, you're going to see it's going to be called pass by value. That's the technical term for making a copy of it. It's going to pass a copy of it as a value. But if you put an ampersand in front of it, that means, oh, don't make a copy. Instead, just use what's already there. Just look exactly where it is. Modify the original paddle, the OG paddle, and put it back into the function and modify that instead. By putting just that ampersand in front of it, what it's now going to do is going to modify the original paddle. And now my paddle is actually constrained. And I can put a debug here. And by putting a breakpoint inside this if statement, oops, I missed one more file. So watch here, it hit this breakpoint. See how this position is negative 4.6? Gets set to 0. I go out, and now my right paddle position is properly constrained to be 0. This is because we told it now to modify the original. There's another way that you can fix this without passing in this. This says, hey, don't make a copy, give me the original. You can also say, well, go ahead and make me a copy. But instead of just passing in a copy of the value, what you can do is give me a copy of the pointer that's passed in. When you put an asterisk in front of it, you're asking for a pointer to the paddle, which means, hey, give me a pointer to the paddle instead of giving me the original. Now, whenever you use a pointer, you have to remember that you can't use the dot operator on it. You have to use the arrow operator with a pointer. And take all these and replace these all with the arrow. And now it's going to pass in a pointer. The only issue is that now this function here requires a pointer to these variables. You guys remember how to get the memory address of a variable when you're passing in it? You put an ampersand in front of it, right? Now I'm still passing a copy, but what I'm passing a copy of is the memory address. And this works exactly the same way. So there's functionally no real difference between these two methods, aside from the fact that one is using a pointer and one is using a memory address. So this is actually comes down to a coding standard for how you want your game to be architected. And there's different ways to do it. If you do it either way, it's totally fine. We err on the side of like passing in pointers in most cases. However, there's an argument for doing it this way too. Actually, the semantics of this are a little bit. You need a little bit more context for this. So the reason why you would use this pointer over the ampersand is purely a style consideration. And the reason why it's a style consideration is where do you want to do your error checking? And in the case of this, whenever you have a pointer, I don't know if you guys remember, but if you ever have a pointer, there's an opportunity for this pointer to be invalid and can cause your game to crash. For instance, if I ever called this function here and I passed in null or 0, this will actually immediately cause my game to crash because now I'm trying to get see how it crashed? It just threw an exception here. Because this right here is all zeros, and it's trying to get the position of something that's 0. And because it's a pointer, I'm allowed to pass in 0 for it. If this was not a pointer, if I go back to putting it back to be pass by reference means don't make a copy. I change all of these here. If I change this back to be an ampersand, there's no way for me to make this thing crash because I can't pass in null to this function. If you look, I cannot do this anymore. This right here gives me a compiler error saying I cannot pass in null. So really, the difference is that if you want to use pointers, because oftentimes you're working with pointers quite often in games, and you want to pass that into a function, you might have to, inside that function, if this thing is actually a pointer, oftentimes you'll see this, where if paddle is not equal to null, you'll have another if statement here, like that checks to see that it's not null before you do all of this work. Because if you don't do this, and then you try to dereference this paddle by using the arrow operator, and this thing is null, you'll crash right here. So oftentimes you'll have this if statement right here, which will mean that you'll be able to safely run this code only when this paddle variable is valid. All right. So this pattern that I've been doing, which is to break things out into functions, can be done for more than just the constraining of the paddle. I can do this for other things as well. Like I can take all of these things. I could consider moving a lot of these things into functions too. Some of these functions will be very simple. Like for instance, I have all this behavior that's like loading sounds and loading music. But instead I can move all that stuff out if I wanted to into a function too. Why don't I take all this stuff and break this out? Because there's a lot of code here at the very beginning, and if I wanted to, I could simplify a lot of it. So I'm going to do this. I'm going to take all of these variables here. I take all of this. I'm going to actually move it all into a function too. I'm going to call this function init sounds. It's going to take no arguments in this case. And the reason why it's going to take no arguments is I'm going to move all these things to be global variables. So I'm actually going to just do this. I'm going to declare all of my variables at the very top. Because these are sounds I'm going to be using a lot. And there's my functions. Here are my variables here. And I take all of this code that I'm doing. I'm just going to call init sounds. So I just removed all that code from here. Now all that stuff has been condensed into a single function. I go down to the bottom here, write my function, like so. So there's all my functions. And notice here it's got little red squigglies where it's returning 0 because this thing has no return type. And I can choose what I want to do here. I can make this thing bool, which will mean that this function will return true if everything succeeded. So I can say, hey, return false if it failed. So I can do that here and here. And if I get all the way to the bottom here, it means that I succeeded, which means I can return true. So that when I call init sounds, I can put an if statement around here. And just like load from file, if I fail to init sounds, which means I put an exclamation point in front of it, I can do a standard cout, fail to initialize sounds. And then I can do a return 0 here. This function here now is responsible for loading all my sounds. If I want to go and load more sounds, I just go to the very bottom of my file and look at all this code that's here. I can just add more behavior here. In fact, I can remove the parts where I'm declaring variables because I've already declared them at the top, like so. Let's do this for one more block of code, and then I'll be done. Two more blocks of code. So one of the most common, the first things that you do when you're making a game is actually to break apart all of your game logic and your rendering logic into two separate sections. What I want to do is I want to take all of this logic here and move it into a function, and I want to take all of this logic here and also move it into a function, like so. Okay. So let's first figure out how we can get this thing to work by moving all of our rendering logic into a function. I'm going to take all of this, which is all in one place, and put it in the same function. I'm going to make two functions, and these are very common functions. One is going to call update, and one is going to call render. An update loop and a render loop are two distinct phases of a game. You typically will update all your game logic, and then you'll render everything that is a result of that. So this is actually very easy. Render, all it's going to do is I'm going to take all of this stuff here. I'm going to cut it. I'm going to call render right here instead, like that, and paste it down here. Notice I get a bunch of errors here because now it doesn't know what these variables are. Shape, left paddle, right paddle, score text, window, it doesn't know what these are because all that stuff exists outside of this function. So what I'm going to do is I'm going to move these variables outside into the global variables. So every single one of these variables that I have, shape, left paddle, right paddle, and score, I'm going to move out to be global. So I take these texts here, I'm going to move them up here. I'm basically just moving these things. I'm going to take my paddle and my shape, I'm just going to move them up here. And let's see what else I have that I'm missing down here. Looks like it's still missing window. So window I'm not going to move out, because window I want to stay and declare it here. I just want to show you guys that this is something I want to pass in and how to pass that in. I'm going to create an argument that's a render window, just like this. And guess what? I'm also going to pass this in. I'm going to pass this in as a reference, like so. And then at the bottom, I'm going to make sure to pass this in, a reference here. And then in render, I'm going to pass in window. Now I'm going to do the same exact thing for all this stuff here. Call update, like so. So this is my game now, update and render. You see how all my logic is not there anymore? It's a much more straightforward function. I'm going to put my update right here. It looks like I have window and velocity, so I'm going to pass in my window. Take this guy, move him up top. And again, I'm going to pass in the window here. Pass in the window here. All this work here for delta time, the comment pattern is actually you tell update what your delta time is. So I'm actually going to move this right here outside. Put it right here. And what I'm going to do is I'm going to pass a second argument, which is just going to be delta time. Oops. I'm just going to do this. And now I'm going to also pass that in as a reference, like so. Here's my delta time. So here's my update function. It's still doing everything that normally it does, so all the behavior, except for score. I also need to move score. Oh, because I declared that right here. And the reason why I'm making all these things global variables is because I could pass them all in as arguments, but the number of arguments that I would have to pass in would get really long. And so I want to keep this thing down to like 2 if possible. It looks like it also has issues here because it doesn't like me declaring a sound buffer. Oops. So it looks like some of this stuff is having issues with. Sound buffer seems like it cannot be declaring the sound buffer inside the global variable. So what we're going to do here, we go down to where we're initializing sounds. Some of these things, whenever you're breaking things out into functions, you might encounter problems like this where, oh, I can't actually move these things out into global variables. And so maybe SFML isn't really great with moving these things out. So what we'll do in these cases, we're going to actually have to pass these all in as arguments, which is fine. This is why we do this. I'm going to take all of these, which were global variables, put them right here. And we're going to pass these all in as arguments so that we can initialize all the sounds properly. So we have sounds, we have, how many do we have here? Sound buffer, sounds, sound buffer, music. Oh, one other thing too. One thing we can do here, there's actually a way we can do this without passing all these things as arguments. Here's what we're going to do. We're going to make all these things pointers. And we're going to change all of these things and we're going to declare memory for them right here. The reason why I'm doing this is because even though I moved them out to be in the global space, it was having problems because it couldn't create those sounds properly in the global variable space. So instead, what I'm going to do is let it create those sounds inside this function right here. And then anytime I want to play the sound, call play. This work that I'm doing seems like a lot of maintenance. I mean, I had a game already all set and running. Why would I need to go through and do all this work again? The reason why is that this thing that I'm doing right now is called refactoring. And refactoring is actually a very important thing to understand why or how to do it, because oftentimes you'll get into a point where your code kind of becomes unwieldy and difficult to work with. And you need to break it up into smaller chunks so that people who are working within the code can understand a little bit more about how the game is working. For someone else who's never seen this game of Pong, maybe they just want to know how rendering is working in your game. Well, they can just, all they have to do, they don't have to look at anything else. They can just look at the rendering portion of this game, as opposed to just looking at the entire function for where things are being rendered. So see how the game looks exactly the same and is behaving the same, except there's no music, which we'll fix right now. Remember where we're playing our music here. So all this work that I did to make it out into these 4 functions is more like, I think for Pong it's actually fine to put all in one function. However, this thing that we're doing here, update, render, initialize sounds, constrain paddles, for next class we're going to be doing a lot more of this. Because this idea of breaking apart work into smaller pieces is exactly how object-oriented programming works. It's all about taking complexity and making it simple. You can't really make a game that's as complex as like Overwatch or as WoW without simplifying a lot of those problems down. There's no way you could make a game like that inside one giant main function. So understanding how to break that apart is actually really important. I could even do one more break here. I'm going to do one more. One more function called init. Move all of this stuff down there. And make a void function called init. And there we go. So this is what our game has now become. With all this, we have one function to initialize everything, text, score, paddles. We have another function to update the game, and another function to render it, and that's it. One of the benefits to doing this too is that if you ever wanted to say, I don't know, like disable certain pieces of the game, like here's my game, it's running great. What I can do is, if I just put one little comment here, stop it from updating. Now my game will render, but nothing's happening. Or I can comment out the rendering, and you'll hear the game, but you won't see anything. All right. And although we don't really want to do this, we don't really want to comment this out, the fact is that you can comment out sections of it a lot easier. And looking at this, if I just told you this is Pong, you wouldn't necessarily know that because you'd have to drill in a little bit deeper. But at least you can figure out what you care about. Like, do you care about how the game is updating? Then you look at the update function. Do you care about how the game is rendering? And then you look at the render function, or how the paddles are being constrained, right? All right. So let's go over the final. Are there any questions on this? I know there's a lot of stuff. Like, it's all like not super exciting, but at the same time, this is also really, really important. Like, doing this work is like, it's one of the most common things is that you can easily tell who's like learning, a beginner programmer versus people that have been programming for a while, because the people that have been programming for a while understand that the bigger your code gets and the more complex it gets, the harder it gets to work with. And understanding how to manage that complexity is like a big part of your job, is managing that so that other people can work with it.